Welcome back to this week's Taproot Podcast. I'm joined by Ken and Mark. This week, we're going to be talking about why accidents repeat. And I want to start us off with a quote from a former president, which is, "Fool me once, shame on me, fool you, you can't get fooled again."
Say that 3 times quickly.
Can't even do it.
Can't even say it once.
So when we think about accidents and repeats, you know, we see these things happen. We've talked to different people and they say, I have the same problems happening again. What is your kind of first thoughts when you hear that people are having the same types of problems over and over?
My first thought, it's a good thing it didn't get worse.
Okay.
Yeah.
Worse in what way?
Worse in like, oh boy, we only had something fail. It was a downtime or whatever. But this time we blew up the whole place and 6 people died. Oh, that's much worse.
So when we think about like repeats, there's, you know, like the standard, like, oh, the same piece of equipment just keeps breaking again and again. Or you could have
the same injury.
Same injury, yeah. We just everybody's got cut hands. So there's different things that can repeat, and you're saying that sometimes it can get worse. So what are people looking for then in this case?
What are they looking for?
Yeah, what are they looking for incidents or repeats? How would they know they've got a problem like that?
Well, that's a good question, because some people don't, because they don't have a good database and they don't have a way to trend things. And they don't even know that they're happening over and over again. It happens on a different shift. A different guy was in that day. They don't pass the thing along.
Yep.
Or it could be even different factories, similar factories, and they're having them happen here, and they're having them here, and they happen over this other place over here, and they aren't talking to each other, and it's the same incident because, I don't know, they have the same equipment, they're using the same maintenance plan, they've got the same human error built into the system, and it's just happening over and over and over again. And you don't see it happen fast enough that you recognize, wow, this happens sometimes every week.
Right.
And you don't even notice.
I think
that's normal. Hey, it always breaks.
I think it's quite often too that when you do recognize it's happening over and over, whatever that it is, there's probably a huge percentage that you don't even know are happening over and over. So the ones that you see are just usually the tip of the iceberg of the happening over and over again.
So a failure of trending at the is we'll say one issue that might lead to repeat incidents. Sure. And you could have, I didn't even recognize it's a repeat, or I'm not doing any trending, and therefore I don't recognize that I have this repeat issue.
Right. Oftentimes until something really bad happens, like you had mentioned, and then when we go back and retroactively look at our trending and say, oh, yeah, that's been happening 100 times. So.
In all of them, if they're repeating, that means there's something wrong with your corrective actions. Because your corrective actions, if you're doing any, don't stop it from happening again. Right. A lot of times people aren't doing anything. They're addressing a symptom. The symptom is a part failed. What's the corrective action? Well, put a new part in. And just keep doing that. As long as there's new parts, we'll just keep doing that.
Right.
Until something worse happens.
Run out of parts.
So you've got the failure to trend, which is know that I even have a repeat problem. And then now we've got this other area, which is not only do I have a repeat problem, what I've been doing in the past to fix this repeat problem is not successful.
And that's always true.
So taking an example in this, when I was going through manufacturing, one of the problems that we had dealt with was we had these ceramic inserts that were breaking. And this was like probably if I had really looked at the data, I'd say this is probably one of the largest costs for why we scrapped parts. Would be a ceramic insert breaking, and it would cause this big gouge, and you don't have enough stock material that you're removing to be able to fix that gouge that had occurred when that insert broke. And we probably would have at least 2 or 3 of those occur in a week, maybe more if we had really been noticing it. We probably would have had more that got reported and found. And it was, at the time, a lot of people were just thinking this is just a thing that happens, right? Maybe we have bad. Do we have bad inserts?
Just the way it is.
It's a
What's going
percentage
on?
failure, right? It's a percentage of these are just going to fail.
Yeah, they
right?
fail after. Well, they fail after
Yeah.
a certain amount of time.
Just
That's just what
breaks.
happens, and how are you going to know when it's going to fail?
Right.
So if you just kept going with normal operations, well, we're going to scrap some stuff out sometimes because they break. You end up having a lot of quality defects, and you're really not figuring out, one, that hey, maybe there's something we're doing that's contributing to this, and two, recognizing the cost of that. So if you trended this data and said, hey, we had a broken insert, how many times have we had broken inserts in the last month, and what was the dollar amount to that? Well, now you can start adding a dollar value to this. It's tens, hundreds, whatever amounts of dollars that is. So trending, I think, is a good portion of that. But like you're saying, Mark, even if I know that I have a repeat problem, doesn't mean that my analysis was good and that I have identified what to fix.
So take that times 10 and make it human error. I can ask people, at least you recognized after a while that you had a repeat problem. A lot of people don't recognize repeat human errors at all because, well, that was Joe made that error, and Frank making that error is a whole different thing, right? And so it's not like a repeat. It was Joe made the error.
Those
and
are
it was
two
Frank
separate
made the error.
problems, right?
Those are Joe and Frank problems, not repeat issues. And so if you don't have a good way to investigate people, first off, that you ask somebody, what is the cost of human error at your facility? And they'll look at you like, oh, I've never thought about that.
They don't have a number.
We don't have a number for that, which really they ought to really have a number for it, because almost all problems are human error related. So even if it's a part failing, there's usually a reason why it's failing. And that reason why will usually get back to somebody's decision, somebody, the way they're installing it, somebody, the way they're operating the equipment causes that part to fail.
The maintenance they're doing on it.
Yeah, exactly. Mm-hmm. And so there's almost always it falls back to a human error. And so all of your loss, if you said 80% of our losses here are due to human error, and you had a number for that, that'd probably be a good number, or at least a better number than, I don't know.
However, we know that doesn't lead to much in the way of understanding the repeat problem portion of just saying, oh, it was human error, right? Because I can think of repeats where it was the same person that kept making a mistake, and even if the mistake was slightly different, it was that person, right?
It's at the very top of the root cause tree. Human performance difficulty, that's all we're talking about. Now, why it occurs, we don't know.
Most people don't get below that. They stop at that
They
human
stop
performance problem.
They stop at that
human error.
person. They made that mistake again.
It was a Frank problem, or it was a Joe problem.
And the corrective action is fix Frank or Joe. That's the corrective action that's put in place.
If you
right?
get desperate, first off, you got to counsel them to be more careful next
Absolutely,
time.
right.
And then if it happens over and over again and you don't like Joe, well, you're going to have what do they call it? One place I work, they call it have a final commitment meeting, which means you bring him in and say, listen, buddy, if this happens one more time, you're out of here. And that was he was supposed to commit then
to not doing it again.
Never doing it again.
Right.
And that was supposed to fix the problem. And the answer was, if he was self-reporting that it happened, it would never happen again, right?
So we identify here that we have repeat problems. We know that those problems are likely related to human error. Why is it not just fix the person then? Why is that not going to work if we just try to fix Joe?
Well, a lot of times, just understanding that it's a human error isn't oftentimes even enough. We're getting to that point because we oftentimes don't even understand the problem that we're troubleshooting at this point. We don't even know what it is that the error is occurring in, what problem we're having, and it's because we haven't gathered the right information. We haven't done a good evidence collection phase of our investigation, and all we know is it screwed up while Frank was doing it, so it must be Frank. And we haven't gathered any real information yet.
And Frank was the last person to touch it before, so he was the last safeguard before the accident. Now, how many safeguards failed before Frank got there, we don't know.
We didn't gather any data.
And why Frank made that last error, we don't really know. But we just know Frank touched it last, so it must be Frank.
So if we just try to fix Frank And let's say that's a thing you could actually do. Let's just say if
This
I could
hypothetical?
if I could tell Frank to be
Turn
more
that
careful.
screw 3 times more tight up there.
Yep.
If that somehow worked,
Wait. You do it by having more training
well, of course, if I just really tell him to focus next time. So
and have more training.
if I could fix Frank, that still leaves the possibility of that error for other people to make.
Right.
So I think about, and again, I'll tie this back into.
But everybody sees Frank get punished. They won't want to do
that
that.
they won't make the same
They
mistakes.
won't
Frank
want to
does.
make the same mistake because they saw Frank get
So
punished.
I'll take this back to my example that we had. So we had these ceramic inserts breaking, and we did not understand what was causing it. Now, in this case, you've got an equipment failure, right? It's a broken insert. Well, we had to get some data. So what we did is we started collecting information, and anytime we had an insert broke, we stopped in here and we recorded speeds, feeds, what was the insert. We kept it, brought it in just to kind of keep and see if they were breaking in the same way, because there's a lot of different things that could cause it to break.
There's a lot of factors you have to consider.
Yeah,
right?
so speeds and feeds is one, but
So
also
is it really a repeat, or is it a different thing that just caused the same outcome?
yeah, so because you can break an insert by over tightening it. You can break an insert by running it to making too deep of a cut or making too fast.
So
of a
Joe
cut.
may be over tightening while Frank is making too fast a cut.
So we started collecting this to try to see if there was something in common. So this is kind of where we're talking at this initial thing of we need to gather information and understand, because a human error or that mistake, that's the start of an investigation point. At least that's what we say in Taproot. It's the start of an investigation. We don't stop at human error. We start there and say, okay, what do we now know? Now, as you're getting this to get, how do you understand a repeat? You talked about not going deep enough. We know Frank or Joe or whoever we were in this fake scenario. Frank here made a mistake.
Operator A.
Yeah, we'll say operator
Mechanic
A.
A.
So, in order to understand a repeat problem, what kinds of things do I need to look for? What kinds of information do I need to be, questions do I need to be asking in some cases?
Yeah, this is where you're going to start looking at the different things that affect that person. So the different areas of human performance that affect the person's performance. So you're going to be looking at like his physical environment that he's in. You're going to look at the procedures he was using. You're going to look at how we as a company enforce all our policies. All of these things affect how a person performs their jobs. And those are the things that you need to be looking for during your investigation, and ask yourself, well, how has management been involved with this particular item? Or how is what kind of communications were going on at the time? All of these things need to be taken a look at, and you can't miss any of them. You've got to make sure you catch all of these, because all of these things affect the performance of the human. And if you skip over one of those, it's a good chance you're missing a possible human performance problem.
I would do one more thing. Lay out the complete sequence of events that happened. So you might find in the one case where, gosh, was Joe over tightening or Frank over tightening? I don't remember. But if you look at the one case, there was over tightening. It's a different sequence of events than cutting too deep. That's a different sequence of events. So first thing you got to do is lay out that sequence of events and see what's happening. Now, if you were doing this, I would say generically, in other words, you want to analyze this process, you could then say, okay, some of these were over tightening events. Some of these were cutting too deep events. And you can all put those on a generic snap chart of what's going wrong. You can then look at the numbers of those you had. There were 6 of these and 4 of these. And maybe there were some one-offs, other things that happened. And you can say, okay, then it starts to be like a FEMA. These are all the things that could go wrong. Then you take each one of those and say, okay, if he over-tightened it, why did that happen? And then you get to Ken's questions of all those details that go below that causal factor, the over-tightening causal factor. And then if it was cutting too deep, then once again you'd say, well, what are all the things that could cause somebody to cut too deep? Well, and I got to go collect that information and see if any of that was applicable to this. You don't know. And the interesting part is, if you're going to blame Frank and blame Joe, they probably aren't going to tell you too much about those details, where they were having problems, how they were having problems. Even they might not even admit to what they really did, and they might tell you a story of, well, oh, I didn't over tighten it. I don't know what happened. It just broke. Then you get this generic "it just broke" cause, and the "it just broke" cause is almost impossible to investigate because no one knows
There's no
why
data.
it just broke.
Yeah,
Because somebody's going to get punished, and I don't want it to be me. So it's the equipment's fault.
Right.
It just broke.
Yeah, so having that kind of foresight to say, okay, we're recognizing we have a problem. What information do we need to collect so that we can see these different potential causes of failure? And we know there are lots of possibilities, but how do I actually get some data to narrow it down? That was our thing of let's just collect and see. What we found was is that most of the time, not all, but majority of the time, it was because they weren't rotating the insert every 50 thousandths cut. So you do a depth of cut and you're supposed to rotate the insert, and do a depth of cut and rotate the insert. Because it's got 4 edges, you can get all these cuts in.
It makes sense to you. I have no idea what you're talking about.
So it meant spinning things, moving. So they weren't following
Spinning
a standard,
and moving and cutting and all those things.
And inserts. So they weren't following a standard practice. And it was a best practice that...
Did they know it? Was it in a procedure, or was it just, I know this works,
so
and
this
somebody
gets
else doesn't know?
to what Ken's saying, because we know that there's a standard practice they're not following.
We as a company.
We've found this out by recognizing they weren't rotating the inserts every certain amount of cut. Well, that now becomes where the human performance elements that Taproot gets into. This is where we look at the procedures and the training and the human performance elements, because understanding not only why were they making these not making these adjustments and rotations, but you have to go look at, like you said, the training that they received. Is that standard for just one type of insert or all inserts?
Was it just this guy that didn't know it and know this, or was this a general problem?
Yeah,
across all of our-
so that's the kind of thing is when you see repeats is getting that understanding of information to get down to a root cause. And what we found was there was a knowledge gap across the people that had been brought in and trained that were within like less than a year of being certified, and it was because it wasn't in our documentation that they needed to have this training, that this knowledge about this feature. It was something that experienced people knew and were supposed to pass down, but how well did they really pass it down? Clearly not very well, meaning our training process had some gaps.
I got a question for you. Did it fail every time when you didn't do this turning, or did it sometimes work when you didn't do this turning?
So the turning was to prevent it from breaking. So it's like a wear factor on there. So it would go a little further. You just didn't know when it was going to break.
So sometimes it wouldn't break at all?
Yeah, because if you didn't turn, but you'd turn in the next piece that you ran or something like that.
I gotcha.
So it's like, basically they were treating this wearing component like a run to failure.
So sometimes they didn't even know that they were doing it wrong because it seemed like they were doing it right.
Yeah, because it only failed when you had a part that had so much you had to take off over a certain amount of distance, and maybe to me I was trained that I rotated every new part. I get a rotation. Versus, this one has so much material that has to be removed, you've got to rotate it every pass.
Or maybe you just learned from experience, and I saw him rotate it with every new part, so I think, that must be the standard, and that's what I adopt. When he just knew these parts had less than that much, so I didn't need to.
Well, and there's other elements that we learned with this too, that it's not just about the rotation, because it's like, some of the parts that were coming in have an excessive amount of what we call stock. It's basically how much material had to be removed. And so you can also use this to go recognize, hey, there's a process that we could change back here that would make it less likely for this to happen.
Oh, wow.
And that saves you money, too, because you have less material you have to remove, means faster.
Less time,
You get a lot of improvements really quickly when you can look for opportunities.
And that's oftentimes what you find when you start doing a good analysis of your problem is that, we'll fix this problem here, too, but, wow, we just found some other issues over here that haven't caused us this big nasty problem, but there's efficiencies. And
in theory, they haven't caused a problem, but in practice, we're losing money.
We're losing money.
Know
That's
it.
right. Yeah. So we can increase our throughput or our quality output or whatever by doing a good analysis of the actual problem we're seeing. And secondarily, we can improve our efficiency over here.
And it helps profitability too, because again, if I'm reducing my number of quality mistakes, I don't have to run as much replacement material or have extra spares or whatever.
So let me get this straight. What you should be doing is looking at the whole sequence of events, identifying problems you're having, and doing a good root cause analysis on each of those problems. And that may cause you to discover things you can fix to keep this particular thing from happening again. Plus, the information you collect may help you spot other problems that you can actually improve your system. Even though it wasn't related to the root cause of this, it may help you save money, save time, improve quality, and you didn't even know you were going to find those.
Yeah. So I think those are good guidance for understanding this root cause and finding those root causes. But I think you mentioned early on, there's something else that causes repeats, which is even when I find a root cause, either I don't fix it, I don't do the right corrective action, or I say I'm going to do a corrective action and we never get them put in.
Yeah.
So I think another
The old I have a big backlog, we'll get to that tomorrow.
Yeah, I think another thing of repeats is to look at the corrective actions. So what are some common corrective action mistakes that come in that lead to repeat problems?
Yeah, I think number one is the corrective action that we're putting in place is not related to the actual problem sometimes. We'll have this problem show up and we'll just say, let's just train them on that. Well, there's nothing that says there was anything wrong with our training, but we're going to do a training corrective action anyway
because we know they really want a training corrective action for every problem.
Yeah, because we must have training as part of our corrective action system. So sometimes those corrective actions have nothing whatsoever to do with our actual root causes that we found.
And training is one of the 3 standard corrective actions that you use every time.
That's right.
It's number 1, training. Number 2 is discipline, which starts off with counsel the operator to be more careful when. And number 3, if you got a procedure, well, if you don't have a procedure, maybe you should write a procedure for this. And if you got a procedure, maybe you should make it longer. Add some cautions and warnings.
That should take care of all your problems.
And if you get those 3, you've got to be done, right? Because that's all there is.
Yeah, so I think when we think about why people default to the training, they use the word training to mean a lot of different things. It can mean raising awareness because I've got to tell everybody about this problem so they understand it. Well, that's important, right? You need to explain what happened to the people that it might affect.
But that's not really the training corrective
action. That's not what training, but they'll
that's
call it training.
Explaining what you're doing so they know what it is.
Right. Yeah, but they'll call it training anyway. So I think sometimes, an important step of any post-incident investigation is to share what you found with the people that it would affect so that they can, understand and look for those kind of problems in the future.
Well, and they know why if you, let's say you changed the procedure, just saying.
Yeah.
But you don't tell anybody why you did that, they may go, well, this is stupid. I like the old way better and keep doing it the old way.
Yep. So I think that's a part of the implementation step is that communication phase of why we're doing this corrective action and what we're doing. And I think sometimes people don't separate that from training because we're not this is not training, this is really more implementation of that step.
And I don't want to imply that training is never a solution or discipline is never a solution or changing the procedure is never a solution. I'm just saying we use those way more than they should be used.
Yes, and we use it to cover up for other things that we either don't want to fix or we didn't recognize are a problem in our analysis.
And because they're easy and cheap in most cases.
They seem easy and cheap.
They seem easy and cheap.
But then how many repeats are you going to have?
Well, don't add that in. We don't want to count that. We're just looking at the actual training here. Don't get too deep here.
Yeah. And we don't want to think about the people's time going to training or anything like that.
Don't think about
either.
any of that. That's not to be considered.
So instead of just doing discipline training and procedures again and again and hoping this gets better, what we did is we created the corrective action helper. So with Taproot, you've got that categorized list of root causes that you're going to find as you go through those questions and guide you to root causes. And then for every single root cause in Taproot, we give guidance on how to fix it. So we give ideas. Yes.
These are the ideas. There may be 5 of them, how you fix that kind of thing. You want to think about that and then implement one of those.
So maybe you're not an expert in ergonomics, and instead of just saying we're going to train people on not holding and doing things in a bad way, this is going to give you ideas for how to deal with an ergonomic issue and references so that you can learn more. And so I think the corrective action helper is a really good way to fix one of these problems, which is, are you actually fixing the root cause you found to prevent recurrence? So I think that's one portion of it. But there's some other problems as well with corrective actions that lead to repeat problems. And I think we have it on our investigation grading scale, which is, are you actually tracking your corrective actions to completion? And I think there's a missing element when we think about management, their responsibility in corrective actions.
I remember I was at a place where they would just, the management would approve the investigation, which included the corrective actions. But that was it. They were done then. And they just assumed somebody would be implementing those. And we noticed a lot of repeat incidents. And the corrective actions seemed okay, but we went out to check on how many had been implemented. Let's just say there were 10 we went out to check. It was like 3 of them had actually been accomplished and 7 of them were never done. And when we presented that to management, they were like, no, that can't be right. We know they're getting these things done. And the answer was, no, they weren't. They were going on a backlog. It was on nobody got a bonus or extra pay or somebody looking over the shoulder and saying, why isn't that done? Nobody ever noticed. And so people, if it wasn't my corrective action that I recommended that I wanted to get done, people just didn't do them. Or they maybe they never even found out they were supposed to do them.
They weren't writing those as smarter corrective actions.
No, they were not.
No.
So having a person responsible for tracking, responsible for completion is important. We also think about kind of leadership's commitment to it. I had a conversation with a person about gloves, and they were like, whoa, I can't get people to wear gloves. And what would you suggest that we do for someone not wearing gloves?
Punish them.
Well, so I always have 2 questions, and I've told the story before about gloves, but one is, did they give you a reason? Have we actually investigated why they're not wearing gloves? Which is one early question, because like oftentimes the PPE that they were assigned or given doesn't fit the task they're doing.
Right.
So there's that element, which is you need to investigate that. But the other thing I always push back on as well is, what does your plant manager feel about this? What is their thought on this? Because if your plant manager really cares, if your operations manager or your leadership really cares about this PPE use and adherence, when they are doing their daily walks, when they're being visible, they are going to bring it up. I can think about, the best plant managers that I've known. When we reported out corrective actions, I can guarantee within the next week they would be on the floor checking that corrective action to see if it was actually implemented. And they would go ask somebody about it. Because we might say it was done, but if the operator that's responsible doesn't actually know that it was completed or know that whatever we assigned was added, it's like, oh, we're going to use this new fancy brass tool that won't cause this, problem.
And it's all in their toolbox. All they got to do is go get it.
It's there.
All issued, ready to go.
And the manager walks out. He goes, "What do you know about this tool?" And he goes, "What tool?" And he's like, "Well, it's in the toolbox. I put it in the toolbox."
I don't know why that's in there. Some idiot put that in. Throw that away.
It's cluttering my toolbox.
So those kind of things, there's got to be a level of, I would say, leadership commitment to see things through and to demonstrate what's important. And if your corrective actions are really going to be making a difference, then somebody's got to demonstrate that they're important.
That's all part of the effectiveness check of your smarter corrective action. Too many companies will check that off as complete by putting that tool in the toolbox, and it's complete, and it's done. Without the effectiveness check of management and leadership team coming through and making sure it actually works, it's not a very good corrective action. It's not going to be helpful to you to be checked off as complete and not used. So, yeah.
And then you got a whole other problem, another issue for your next investigation.
That's right. Yep.
They got the tool, but they aren't using it.
Yep.
So if we think about, we've understood that there is a repeat problem. We've trended, we've discovered, we've noticed, we have understood it. We built out our timeline. We identified our problems. We
so
narrowed
if you
down.
weren't doing that before, you've now improved your root cause analysis system
Yeah.
because you realized you weren't doing a very good root cause analysis before.
So now you're doing Taproot and you're doing a good root cause analysis system. That's going to get you down to real human performance root causes that you can fix.
And you've got good suggestions on how to fix them.
So you're now fixing those specific issues. If you're doing something maybe on a more higher risk level, we'll also cover generics.
One more thing. You're also implementing corrective actions that are going to be, I guess I'd call it highly effective, especially if you're really changing eliminating the hazard or eliminating the target, the high potential to get rid of the problem altogether, rather than just adding an additional more training safeguard or a better procedure safeguard or a sign on the wall that says don't make a mistake safeguard. You're not using weak safeguards, you're using strong safeguards. Or if you've got a bunch of safeguards and these things continue to happen, maybe you consider, hey, I'm going to change the whole process. We don't like this process that I'm looking at that is, shows up in my sequence of events. We need to change how the sequence they're doing this so that it doesn't happen the same way. And you can understand that too when you go do this investigation.
Yeah. So I think that's a pretty important thing as you get down to a root cause, that we look for corrective actions that are fixing a specific human performance problem, but also evaluate the strength of corrective actions. So I think you have to have all of these different elements, whether it's good trending, good understanding of what happened, good analysis to figure out your human performance problems. Don't stop there. You got to get a root cause. You've got to have good corrective actions, and you've got to have stronger and smarter corrective actions, and management has to be committed to fixing those.
So let me give you an example. It was a paper manufacturing plant, and they were manufacturing, I think it was toilet paper or tissue, one or the other. And so they had these big rolls of paper, and they were going through these rollers and getting cut to size and then rolled on rollers. And these big rollers that sucked everything in, if the paper being sucked in got wrinkled, it would just continue to wrinkle, and then you would have a wrinkle in your finished product, and that was a quality issue. You don't want your toilet paper wrinkled on the roll, right? You want it to be nice flat.
Right.
So the operator's corrective action was, if you could grab that thing as it was going by and shake it, the little wrinkle would go away and it would continue to work. The problem is, grabbing it, you risk getting sucked into the machine. And you may lose a finger, you may lose an arm, you may get crushed in the machine. So they decided this was bad. Losing fingers and arms was a bad thing.
Good call.
So eventually what they did was they put a big chain link fence around here so the operators couldn't get in there and wave the thing. Now you think that sounds like a pretty strong safeguard, a physical safeguard, right? What did the operators do? And the other solution was, you've got to shut down the whole machine, and then now you got a fence. You've got to go over the fence, get in there, try to adjust this when it's not running, and then get back out and start up the whole machine and hope you don't get a wrinkle again. So what they did was, instead of doing that, they had the ladder, because they had to get over the fence when they shut the machine down. They just used the ladder to get over the fence, go and a guy got sucked in and got killed. And it was, why would somebody climb over this? This doesn't make any sense. It's like he was at fault. He used that ladder to get over there while it was running. They knew that wasn't supposed to happen. And it's one of those examples of, if you don't fix the problem is this is getting wrinkles in it. You're leaving this thing to happen again, even if you put in what you thought was a good physical safeguard, the chain link fence around the machine.
So I think we can sum all of this up. Why do people have repeat problems? They're not doing good root cause analysis, and they should be using Taproot.
And corrective actions.
And corrective actions. So they're not using Taproot. Why they have repeat problems? They're not using Taproot.
They could be using Taproot and not using it right.
Which
means they got their corrective actions, but they never implement them. That's always a possibility too.
Yeah. So I think if people want to learn more, if they want to learn how they can do a more robust RCA process, the best case is going to be coming to either a 2-day or 5-day Taproot course, or checking out that
3-day virtual
3-day virtual
or an Equifactor.
or an Equifactor. So coming to one of our public courses is probably the easiest way to learn more. You can find out that information in the links below. You can find our links to our upcoming public courses. Or if you want to learn about Taproot and share best practice with other users, we also have the Taproot Summit. You can find more about that at taproot.com/summit. So those are 2 different places that you can look for opportunities of learning how to fix your repeat problems.
And hopefully they won't repeat again.
Hopefully they won't
Hopefully
repeat
you'll
again.
implement those good corrective actions and they won't repeat again.
So if you want to learn more, check out the links below.